Hello and welcome to my YouTube channel e-learning arena. I'm your host, process engineer Sayyid Vikas Haider. In today's video I'm going to show you that how we can use the power flow compressor sizing tool to size a reciprocating compressor. So this power flow sizing tool, it is a free tool available on Cooper's machinery website, and you can size 4 different machines, different models or different manufacturers machine using this compressor sizing tool. It is a compressor sizing tool of a reciprocating compressor. So first, when you open this tool, you will see this screen, and first of all you have to enter the composition of the gas, or you can use the built-in natural gas composition. If you have if you want to specify anything specific composition, you can select the custom and edit the component list, and by editing the component list, you can add any of the required component list, and after adding the component list you can also change the composition as well. So for this tutorial I'm going to use the built-in natural gas composition. After entering the composition of gas, you can come back to this initial screen, and there you have to enter the requirements of the compressor, like flow and inlet outlet pressures. So for example, you are going to size a machine which is capable to deliver 20 mm SCFD gas, and then you have to enter the suction pressure. You can enter the minimum and maximum limits of your suction pressure on which this machine is going to work. Similarly, you have to enter the discharge pressures as well. I am going to enter the minimum and maximum suction and discharge pressures, and then you have to enter the inlet temperature of first stage as well. Again, you can enter the limits depending upon the weather conditions, winter and summer, etc. You can enter the range, and again there will be after cooler after the stage, and you can enter the temperatures requirement for after cooler. And again, this another option here is the estimated staging. As you can see that I have used the estimated staging, and depending upon the process conditions I entered above, it is suggesting that a 2-stage machine would be required. If you want to specifically size a stage requirement of your own choice, user can enter the use specified staging as well. And after this entering the data, you can use the auto size option. So I'm going to size the auto size option. So here while using the auto size option, you can give software the requirements of, for example, you want to select a high speed only, or Ajax only, or CB only, or high speed and Ajax as well. So I am going to select the high speed only machine, and then I am going to click the auto size option, and depending upon the conditions, it has sized a machine here. So depending upon these conditions, the tool has suggested me a 2-stage machine with this is frame WG62 is the frame model, and these are the specifications of this frame, and it has 2 throws. The first stage throw is 17 inch and the second stage throw is 12.5 inch. And now you can see that the driver which is going to attach with this frame has not been selected, so we have to select an appropriate driver depending upon the frame. So when I'm going to select the driver, I have to select a driver which should not exceed this 1200 rpm. This 1200 rpm is the rated rpm of this frame. So I am going to double click the this, and then the available options of drivers are here. So remember, I have to select a machine which is equal to or less than 1200 rpm, and again 3000 rpm is the requirement of this frame. So I have to keep an eye on this power, rated power as well. So I am looking through the options that I have. So I'm going to select any machine which is above 3000 horsepower. So there you go. So I'm going to select this Waukesha machine. I have highlighted it. It has the rated load of 3625 horsepower, and it has the rated RPM of 1000, which is less than 1200. So we are okay. So double click it, and it has been selected. So first of all, we have to enter 3 values of this driver. Remember, this is the rated speed, rated RPM. So the operating RPM I'm going to enter is 900 RPM. Then again the auxiliary load. So when the machine is operating, there are some auxiliary load, for example air cooler, which might need some power. So let's assume that the generated power by this Waukesha engine, 120 horsepower will be consumed by auxiliaries. And then you can enter the derating as well. If the engine derates over the time, or depending upon the weather conditions, you can enter the derating value here. So I'm not going to enter any value here. So depending upon this, my entered values, the quick power consumption and the flow that it can handle can be shown here. So after entering these required values, I can go to the this performance tab, and here I can evaluate this machine on different cases. So this is let's say case 1 is I am going to operate this machine at 150 suction pressure and 750 psig discharge pressure with 900 rpm and so on. And again, if I want to check this machine's performance on another case, I will add another case, and for case 2, let's say I am going to use 200 suction pressure and 775 suction pressure, and let's assume that 950 rpm. And again, you can also change the suction pressure as suction temperatures as well, depending upon your requirement. So these are the different cases. So all the cases that you have entered, you can see the list of your cases here. This is the two-stage map of your machine, and the cases on which you want to evaluate this machine, you can view the list of those cases here. So at the moment, the case 2 is selected. The salient process conditions are mentioned here. So if you want a detailed report, you can again select the case you want, and then you will go to this report section. And after coming here, you can generate the report. So this is the detailed report or the performance run of the machine that you have sized on the basis of the process conditions you entered earlier. So this is the detailed report, the unit, that how well this machine will perform under your entered case 1 conditions. Again, I can generate the performance of this machine on case 2. So again, you can go back to the performance tab and select the case 2 which I entered earlier. After selecting the case 2, you can go back to the reports and generate the report of case 2. So this is how you can evaluate the performance of your machine at different conditions. So if you find that the performance is not satisfactory, then you can go back or change the machine or configure different options, or all together you can change the frame as well. So this was the short tutorial that how you can use the power flow compressor sizing tool. I hope that you would have find this short tutorial very useful. If you find this tutorial very helpful, so I would request you to please subscribe my channel and share this video to your colleagues, your friends as well. Thank you very much.